Hello everyone. Hope you are safe and sound. Let us learn a new chapter. We will study chapter number 13, Magnetic Effects of Electric Current. In chapter number 12, Electricity, we learned about the heating effects of electric current. What would be the other effects of electric current? We know that an electric current carrying wire behaves like a magnet. What does that mean? If we have a wire of metal which conducts electricity, and if we put this wire into an electric circuit that behaves like a magnet, let us understand an activity for this. For doing this activity, we will need a straight, thick copper wire. And this copper wire we need to place between the points X and Y as shown in the figure. We have to make arrangement like this by having all these electric components. As we can see in the figure, we have resistor R, we have ammeter, battery, plug and a copper wire placed between X and Y points. Students, I want you to recall that ammeter is connected in the series. Now, we also need a small compass. And this small compass we need to place horizontally near to this copper wire. And when we place this compass, we need to look at the position of needle of the compass. Then we need to plug the key, which means the electricity will be passed when we plug the key. What do we have to do? We have to observe the change in the position of the compass needle. What do you think? What will be observation? When we plug the key, we will have observation like the needle is deflected. What is the meaning that the needle is deflected? The change will be there in the position of the needle of compass, which means where the needle of compass was before, it will change its position. When the needle is deflected, what does it show? It suggests us that the electric current through the copper wire has produced a magnetic effect, which means when we pass electricity through this copper wire, it carries electric current, and by keeping a compass near to it, we have observed that it shows deflection in the needle. By this, we can say that the electric current carrying wire has produced magnetic effect. And so we can say that electricity and magnetism are linked to each other. There is a relation between electricity and magnetism. From this activity, we learned that electric current carrying wire produces magnetic effect. But will there be reverse possibility? That if there will be moving magnets, will they produce electric current? So, for this, in this chapter, we will study about magnetic fields and such electromagnetic effects. We will also study about electromagnets. We will study about electric motors, which involve the magnetic effect of electric current. We will also study electric generator, which involve the electric effect of moving magnets. So all this phenomena we are going to learn in this chapter. We understood an activity that an electric current carrying wire behaves like a magnet. Do you think that we need to know the name of the scientist who has done this activity? Let us know about it. A scientist named Hans Christian Ørsted. He was one of the leading scientists of 19th century, and he played a crucial role in understanding electromagnetism. In 1820, he accidentally discovered that a compass needle got deflected when an electric current passed through a metallic wire placed nearby. And through this observation, Oersted showed that electricity and magnetism were related phenomena. Both are related to each other. Now, let us learn about magnetic field and field lines. Students, we are familiar with the fact that a compass needle gets deflected when it is brought near a bar magnet. We all know the properties of bar magnet, right? Here, you need to keep in mind that a compass needle, in fact, it is a small bar magnet, which means a compass needle behaves like a bar magnet. The ends of the compass needle point approximately towards north and south directions, as we have it in bar magnet. So we will remember that the ends of the compass needle approximately they are pointed towards north and south directions. The end pointing towards north direction is called north seeking or north pole. Please remember this. And the other end that points towards south direction is called south seeking or south pole. Okay, the point which is towards the north direction, that is called north seeking pole or north pole, and the end which is points towards south direction is called south seeking pole or south pole. Simply we'll remember it as north pole and south pole. And by various activities we have observed about bar magnets that like poles repel while unlike poles of magnet attract each other. We all know about like poles and unlike poles of a bar magnet. We are studying it since primary classes, right? So let us have a look at it once again. Unlike poles, so they can be north pole and south pole. They are unlike poles, so they will attract each other. Similarly, if there will be south pole and north pole, then also they will attract. Second case, north north, both are like poles, so they will repel. South south, they are also like poles, so they will repel. So this we have observed through various activities that like poles repel and unlike poles attract each other. If the question will be asked to you that why does a compass needle get deflected when it is brought nearer to bar magnet, what will be your answer? You will say that it is getting deflected when brought near to a bar magnet because a compass needle is in fact a small bar magnet. The ends of compass needle points towards north and south directions. The end point towards north is called North Pole and the end towards south is called South Pole. Okay, so this all reasons we will say.